Welcome back, everybody. So now we are going to work on rule number 2. The first part of this is difference of squares. Rule number 2 is all about special factoring forms. That just means things that are patterns. So listen carefully, please. This is so important. These patterns they come up often enough that you need to recognize these patterns, okay? And so if there's a pattern from now on, since you've learned this, if you do it the long way, the way we've learned already, I will take off points, even if you get it right. I'm going to say that again. Even if you get it right, and you don't do the difference of squares pattern, even if you get the factoring right, I will take off points. So learn these patterns so that every time you see it, you can recognize what it is and go straight to the answer. So our first one is difference of squares, okay? So let's look at, this is our first, so we've got 144 y squared minus z squared. Okay, so, excuse me, this is a y. Okay, so rule number 1 when I'm factoring, is there any greatest common factors here? The answer is no. Okay, rule number 2, now we're going to have to start answering this. So in order to figure out whether we have a special factoring form, either a difference of squares or a perfect square trinomial, those are the two that we will work with, then we have lots of questions we need to ask. The first question we want to ask is this a binomial? And remember, binomial means two terms. So yes, we have two terms here and here, 144 y squared minus z squared. Those are our two terms, okay? So this is a binomial. If the answer is yes to a binomial, and then our next question is this a difference? Now, difference means subtraction. So if this were a plus, the answer is no, and we would go on to rule 3. But because this is a minus, then we say, well, maybe, we don't know for sure yet, but maybe this is a difference of squares. So here's what we want to do. In a difference of squares, generically, it's x squared minus y squared. And that's the pattern, okay? And then the pattern goes into x plus y, x minus y. That's the factored form. I don't like the way that looks. So minus y, okay? So if we could figure out what our x is and our y is, this, the x minus y, that's the generic form. So if we could figure out what our x and y is, then all we have to do is plop it into the pattern, okay? So this is the multiplied form, and then this here is the factored form. So let's look at this. We have to take an even square root of both of those, the 144 and the y squared. So what is the even square root of, what is the even square root of 144? That's 12. And the even square root of y squared is y. Now we need to look at what's the even square root of this guy. Well, the even square root of z squared is z. So if I can take an even square root of both of those, then it is indeed a difference of squares. And so now I just need to take these and put them into the correct x and y over here. And so that would be 12y plus z and 12y 12y minus z. And we're done. Now, let's check this for two reasons. One is I want to show you how this works and why it works every time. So 12y times 12y is 144y squared. 12y times negative z is negative 12yz. Z times 12y is positive 12y, z. And then positive z times negative z is negative z squared. Well, now these are like terms. And what happens with these like terms? They're opposite signs and they are exactly the same thing, so they are both gone. And we end up with 144y squared minus z squared. And that's how it happens every single time. So every time you notice something like this, you should go, oh, that's a difference of squares. I just need to figure out what my x is. I need to figure out what my y is. And then it goes directly into the pattern. I'm done. And that's exactly how you should do this. I do not mind if you do this x and y while you are learning this, but I don't want to see any other long way of doing this, because we need to learn to recognize it and go directly to the pattern. Okay, let's do one more example. So this is our second example. We have 25x squared minus 16. Rule number one, is it a special factoring form? Well, Rule number one, is there any greatest common factors? The answer is no. Rule number two, is it a special factoring form? Well, the first question we're going to ask is this a binomial? Well, the answer is yes. Then we want to know if it's a difference. Well, because this is a minus sign, it is a difference. So now we want to see if by any chance this is a difference of squares. Don't put equals here because this x doesn't actually equal this. Can I take an even square root of 25x squared? Well, the answer is yes, it's 5x. And then what's our y? Well, what's the even square root of 16? 4. So yes, we got an answer of yes to each of those, so that this is indeed a difference of squares. Learn it by its name. And so the pattern is 5x plus 4, 5x minus 4. And it is okay to write it the other way, 5x minus 4 and 5x plus 4. Either way, I usually put the positive first, but that doesn't matter. So that, guys, is difference of squares. Easy as that.